Hello, everyone. Welcome back. So we just discussed what our basic theory of phonology looks like. We talked about how we're assuming that words consist essentially of phonemes and languages have phonological rules that are then used to derive the non-contrastive allophones of those contrastive phonemes. Now, a crucial part of discovering and building up phonological rules consists in identifying that certain sounds share common properties. So for instance, for our analysis of the affrication of alveolar stops in Ordam, we had to identify two natural classes. On the one hand, alveolar stops, and on the other hand, high vowels. So we have those two groups of sounds in the Ordam language. And this fact that the application of phonological processes is dependent upon phonological features makes a specific typological prediction. So something, namely that similar processes should be expected to occur in similar contexts throughout the languages of the world. And indeed, when we study phonological systems across many different languages, this general idea turns out to be true. And as we'll discuss more next week, the phonological feature system that we are going to learn about is based mainly on typological observations about phonological processes and their conditioning environments. So it is essentially said, well, if we find a phonological process that tends to recur in many different languages and similar sounds tend to be grouped together in this way, then we need to try to identify some property that allows us to say, those sounds build a particular group. For the case of high vowels, for instance, this is relatively uncontroversial. The distinction between consonants and vowels is not controversial whatsoever. By vowels, we have essentially no closure or blockage of the airstream in the mouth whatsoever, and our feature high refers to the position of the tongue body in the articulation of that vowel. So that is what we would consider an extremely uncontroversial natural class. And this particular process that we've seen in the Ordam language, where we see this affrication of alveolar stop phonemes preceding high vowels, is something that indeed is found in many different languages. And knowing this fact, having seen a process like this in the Ordam language, makes doing phonology with other languages easier. Once you've seen a process a few times, then you come to expect that such a process would be entirely possible in other languages. So for instance, in Japanese, we find alternations between an alveolar stop, ta, and an alveolar affricate, tsa. Likewise, in the Québécois variety of French, before high vowels, we find the affricate sa rather than a stop. In certain varieties of English, in particular so-called Cockney English, working class, traditionally a working class variety of English in London, we find affricates before high vowels. So the word for T is realized as tsi. And the now extinct Indo-European language Hittite, probably in its immediate prehistory, already in attested Hittite, there seems to be a distinction between a stop ta and an affricate sa, but in the immediate prehistory of Hittite, there must have been a phonemic phonological process that transformed an underlying alveolar stop ta into a corresponding affricate sa. So this, whenever you encounter or try to work out the phonology of a language as a whole or in part in the future, this would be a completely unsurprising sort of process to encounter. And perhaps one reason that lots of languages develop phonologically similar rules is precisely because those rules tend to be phonetically natural. There's some phonetic basis, either in the way that the sounds are produced articulatorily or in the way in which the sounds are perceived by other speakers, that makes it likely that a stop could be realized as an affricate in the context of a high vowel. And here diachrony plays something of a role. It seems that speakers are more likely to produce affricate-like, say, sounds like tsa or cha, affricate-like realizations of stops when those stops occur in the context of high vowels. And these kinds of diachronic effects are sometimes referred to in the literature as channel bias. Let's highlight this term here. And the notion of channel bias, of diachronic phonetic effects shaping the phonological systems of languages has been explored in detail in a book by Blevins from 2004. But we should also note that phonetic naturalness isn't necessarily destiny. There are plenty of languages that do have alveolar or dental stops occurring before I vowels. So in my variety of English, it's no problem for me to say tea for a drink that I would have. My phonology doesn't compel me to say C instead. But the point here is rather that it would be pretty surprising, indeed quite surprising, if we had a process of affrication of an underlying dental stop to an affricate like tsa or cha, if it had two low back vowels on either side. So if we had an instance where ta became tsa, if we had our underlying word, let's say, in an invented language, an underlying form which by a rule of affrication then was transformed into the right vowels here, into otsa. That would be pretty strange. If we were to find a phonetically unnatural process like this one, such processes, insofar as they exist at all, those probably result from from sequences of phonetically natural diachronic changes. So if we were to find such a process in a language, we might think, well, perhaps these vowels, these ah vowels, were originally some other type of vowel which would have been more likely to condition affrication before those vowels underwent a diachronic change and became an ah vowel. But if the distribution is maintained in the language, then it could theoretically be possible for a speaker to learn such a rule. All right, so now that we have this notion that you're going to see similar processes recurring in languages across the world, and that's going to help you do phonological analysis in your life, we can think about how phonemes relate to one another, or the different status of phonemes and allophones in different languages. So in the following section, I'd like to try to clarify the relationships between phonemes and their allophones through some cross-linguistic perspective. So to take one short example, think back to the exercise on the Setswana language that we worked out in our exercise session last week, in which we established that the Setswana language had an allophone of an alveolar lateral, and that this sound had two allophones, da and la, where the stop allophone occurred in the context of high vowels, I believe was the environment that we found. So what we were able to determine for the Setswana language is that the two phones, the two sounds da and la, are not contrastive. They are allophones of a single phoneme. In virtually all varieties of English, as far as I'm aware, we can find minimal pairs of words like dad and lad, which show clearly that these two phones, da and la, belong to independent phonemes. So in that case, here for Setswana, we have a phoneme diagram that looks something like this. Maybe I'll try to draw that for you. So yeah, all right, in Setswana, we have the underlying phoneme la with the two allophones t, and l. But in varieties of English, that minimal pair. So recall from last week's lecture that minimal pairs don't necessarily show us what the underlying representation that should be established for a phoneme is. In this case, going to assume that the underlying representation is equivalent to the surface representation in these two words, dad and lad. So English has two phonemes corresponding to these two phones, la and da, whereas Setswana had two allophones. I guess that should be a da over there. I think I wrote a voiceless stop instead, whereas Setswana has allophones of a single phoneme. And if you read pages 31 through 34 in your textbook, there you also see a similar demonstration where Hayes discusses how English and Spanish both have sounds which can be set up as an underlying phoneme of a voiced alveolar, or in Spanish probably more likely dental stop, and similarly corresponding voiceless stop. While these in English, there is a brotic, there is an alveolar tap, ra, which is simply an allophone of those two phonemes, but this makes its own phoneme, ra, in Spanish. So English and Spanish here both have similar, if not identical, phones, but they have the distribution of the allophones is different. And the same applies to the voiced interdental fricative, the, which constitutes its own phoneme in English, but is merely an allophone of da in Spanish. So we can illustrate this in a couple more languages below here. And we'll start by comparing, we'll use Spanish as a point of comparison, and we'll look here at the Garifuna language. The Garifuna language is an Arawakan language that has speakers mostly in Central America and Northern South America. We're going to start with some Spanish data. In both Spanish and the Garifuna data, we're going to be looking at the same set of phones, a bilabial stop, ba, the corresponding bilabial voiced bilabial fricative, va, and the labiovelar glide, wa. We'll start by conducting a little bit of a phonemic analysis with these phones in Spanish. So here's our Spanish data under point 6. And an important point to note in this data, in some cases we have morphological word boundaries. For instance, in number 10, we have words like una belga, a Belgian, or una huelga, a strike. And for the purposes of the phonology, we're going to ignore those morphological word boundaries. Those probably constitute one phonological word, the combination of the indefinite article and the nominal form. So to begin, we will apply the method of local environments that we learned about in last week's lecture and exercised a little bit. And we're going to look for near minimal pairs, of course, to try to see what sounds probably are contrastive and look to see if there are any complementary distributions. So I've already drawn up here in the following table the local environments. So we can see, for instance, the stop, we have it occurring after nasals and at the beginning of a word, preceding a variety of vowels, a, o, e. And we also have it occurring in at least one data point, that's data point number 7, the word hembra, occurring between a nasal and a tap. The voice bilabial fricative, va, meanwhile, we find this occurring after a variety of vowels. So this already should should stand out to you. This fact ought to be notable for you, that we can find this sound only immediately after vowels. So as I said here, I've marked the word boundary, for instance, in number 10, but we'll consider that a morphological word boundary, and we'll just ignore that. So this is important. This sound only occurs after vowels, and otherwise it mostly, in most cases, the following sound is a vowel, but it is at least a sonorant. So in data point number 11, the word, where is 11? There it is, publicaria. There we have a lateral following it. And finally, the sound wa, this glide, we see it occurring between vowels, but in 18 and 24, we see it occurring at the beginning of a word. So let's check 18. Yeah, the words hueste, host, and huésped, guest. We find it occurring at the very beginning of a phonological word. And from here, we can note, let's see, here we can see there are some identical local environments between the stop ba and the glide wa. So here it can, both of those sounds can occur at the beginning of a word before the vowel a. So that should be an indication. So since we have both the stop ba and the glide wa are found in the context left edge of a word followed by the vowel a, this is an indication to us that these belong to different phonemes. Then, on the other hand, what we see for the is that the never occurs at the very beginning of a word and is always preceded by a vowel. It's also never preceded by a nasal. But we also see wa occurring in some environments identical to the. So we find wa occurring between two a vowels, for instance, and also the bilabial fricative the can occur between two a vowels. So we can take that and say, these two sounds, we find those each in an identical environment, and we can draw the same conclusion. These two sounds, va and wa, belong to different phonemes. And instead, it appears then that ba and va stand in a complementary distribution to one another. It looks like va occurs after a vowel, whereas the stop ba occurs elsewhere. Based on our criterion that the elsewhere allophone should be posited to be the underlying representation, we can take the phonemic relationship to be something like this. There's an underlying voiced stop, which has the two allophones of a voiced bilabial stop and a voiced bilabial fricative. Good, and we're able then to derive the fricative using this rule of spirantization. So the term spirantization here usually refers to a process whereby a stop is transformed into a fricative of some kind. So here we can refer specifically to the sound ba, and it becomes a fricative when it is immediately preceded by a vowel. So that was the left context for our process. So there's our representation of that phonemic relation for Spanish. Let's now turn to the Garifuna data. So we're looking at the same set of three phones in Garifuna, and we'll collect these local environments once again. So let's study these local environments. So we see the stop ba occurring at the beginning of a word, but also in between some vowels. It can occur between virtually any of the vowels that we find in the data, a, e, u, a, and it occurs between vowels in a couple of cases. The fricative v also occurs at the beginning of a word, and we can find some identical local environments for the stop and the fricative. So for instance, you can find a number of, at least a couple of identical local environments. So we can say here that both the stop b, the bilabial stop b, and the bilabial fricative v occur in the context at the beginning of a word before a, and also at the beginning of a word before e. So again, that suggests that these two phones, ba and va, belong to different phonemes. And then when we turn to the glide wa, here we need to look a little more closely. So we see the glide wa occurring at the beginning of a word before the vowel a, and at the beginning of a word before the vowel I. And in number 14, in number 14, we see it occurring before two ah vowels. So we can find some identical, and do that. Let's clear some of those highlighting. We can see wa occurring in the same local context as ba in some cases. So ba also occurs at the beginning of a word before a, and that's the only identical context for ba and wa. So it looks like ba and wa, their shared common local context was the left edge of a word before the low central vowel a. So these belong to different phonemes as well. So what we're left with here now, if we consider this carefully, let's look at the right context between the fricative va and the glide wa. The fricative va, we always see this before a front vowel on the right side. So the vowels e, a, and e are plus front. So the tongue body in the articulation of those sounds is going to stand closer to the front of the mouth. So let's talk about this set of sounds, e, a, and those are plus front. And wa, on the other hand, we only find it preceding a and the high central vowel I. So there is a complementary distribution here. The complementary distribution we can describe as saying that the fricative va occurs before front vowels, while wa occurs elsewhere. We find it before non-front vowels. So it would be nicer to have some data here in which it occurs before a back vowel, but we couldn't easily find some data points reflecting that. So it looks like then we can then posit a process, our phonemes, since the phone wa appears to be the elsewhere allophone in this case, occurring before both central and back vowels. We'll posit that the underlying representation for this phoneme is a glide wa, and that glide wa has then two allophones, the glide wa and the stop va. We write that over here as well, just to make sure it's clear. And our two allophones were wa and the va. With the following rule then, based on the context in which we could establish where the fricative, the bilabial fricative va occurs, we can write a corresponding rule. So a lot of features have to be changed here, starting from an underlying wa in order to transform that wa into a bilabial fricative a number of features have to be changed. It's no longer velar, it's no longer round. That changes from simple labial to bilabial, and it's going to be a fricative, and it's no longer going to be a glide. And this occurs in the context of a front vowel. We could represent this by this featural change, but it would also be completely fine in this case to represent the rule in a more simple way, namely to say that an underlying wa is transformed into a bilabial fricative va in this context. So when a rule isn't affecting more than one sound, it's completely reasonable to simply use the symbols of the International Phonetic Alphabet. Okay, so having seen these two cases, we can draw a couple of general conclusions. So we can see that Spanish and Garifuna both have the same underlying phonemes. Recall for both languages, we posited an underlying phoneme of a bilabial stop and a labiovelar glide. Well, but the allophone of the bilabial fricative va belongs to a different phoneme in this case. It's a phoneme of a different contrastive sound in the respective languages. In Spanish, the process of spirantization transformed an underlying stop into that bilabial fricative, whereas in Garifuna, the hardening of the underlying glide transformed the underlying glide into a bilabial fricative before a front vowel. So we can compare the sounds in this way. They have the same group of phones, and they each have the same phonemes, but the mapping of phonemes onto allophones is slightly different in each case. So this shows us that the mapping of phonemes onto allophones is certainly something language particular. So having seen that there are these language particular facts about the relationships between phonemes and allophones, we can next turn to the notion of what the mental status of phonemes in fact is.